All right, in this video, we're going to do example 4 and 5 in section 5.8. We're going to do some more word problems. It says here in example number 4, each leaf of one particular philodendron species, I guess some sort of a plant, right, is approximately a triangle. So we have a triangle, helps me kind of visualize. A typical leaf has an area of 320 square inches. If the leaf is 12 inches longer than its width, find the length and the width of the leaf. So we're trying to find the dimensions, length and width. So our final answer should be that, length and width in inches. It says something about a triangle, and then it says about that area of the triangle, right? And so do you know what the area of a triangle is? Well, hopefully you remember that the area of a triangle is length times width divided by 2, or 1/2 length times width, or base times height. You can use those words also. So area is base times height divided by 2. All right, well, what does it say in our problem? It says here if the leaf is 12 inches longer than its width. So we don't really know what the width is, right? Could I call that W? And I don't really want to call the length L because I'll have L's and W's, right? So what do we know about the length? Well, we know it's 12 inches longer than the width. So if the width is W, then the length is really W plus 12, isn't it? It doesn't say 12 times longer, it just says 12 inches longer. So I want to add 12 to my width. All right, now that I have those two variables, I should be able to plug all my information into my area equation, including the area that's supposed to be 320 square inches, right? All right, so I have the area of 320. I have a length, but instead of calling it L, we're going to call it W plus 12 because it's 12 inches longer than the width, times my width divided by 2. That's my length times width divided by 2. All right, this formula looks kind of ugly, right? I don't know about you, but I prefer to get that 2 off the denominator. So what I'm going to do is I'm going to multiply both sides by 2 so that I can get rid of that denominator. Making sure that I multiply both sides by 2 to keep the equation balanced. The 2 on the right side in the numerator and the 2 in the denominator reduce each other. So on that right side, you should just be left with that W times W plus 12. On the left side, when I multiply by 2, 2 times 320 is 640. All right, now that I don't have any more fractions, any more denominators, what I can do is I can distribute the W through, and I can move the 640 over by subtracting it. I've now moved everything to the same side and put it in order. It looks like a quadratic, right? Has 3 terms, no GCF. To me, this looks like a basic factor problem. I need to find numbers that multiply to negative 640 that add to positive 12. You might need to take out your calculator, try a few numbers. Eventually you'll get it. I ended up getting W plus 32 and W minus 20. Now that my factors are set equal to 0, I can set each piece equal to 0, and I end up getting W equals negative 30 and W equals positive 20. Okay, but what does that mean? What did W represent in our scenario? Well, W, remember, represented the width of this length. And it doesn't quite make sense for our width to be negative 32 inches. But I can say that the width is 20 inches, right? Now remember, the question is asking us both for the length and the width. If we know that the width is 20 inches, what do we know about the length? Well, don't we know that it's 12 inches longer? So I should be able to take that 20, I should be able to add 12 to it, and I should be able to figure out what the length is also. So labeling my answers clearly, I have that the width is 20 inches and the length is 32 inches. Perfect. All right, let's do one more in this video, example number 5. It says here, for certain people suffering an extreme allergic reaction, the drug epinephrine is sometimes prescribed. You've heard of an EpiPen? That. All right, the number of micrograms N of epinephrine in an adult's bloodstream T minutes after 250 micrograms have been injected is shown in the table at the left for several variables of T and can be approximated by this equation. So if you look at the table, it says here after 2 minutes, after 2 minutes of injection, there's going to be 160 micrograms of this drug in that person's system. After 5 minutes, it's going to go up to 250. After 8 minutes, it's going to drop down again to 160. So it kind of goes up, and then it kind of goes back down. It peaks and then comes back down. They can kind of estimate an equation that goes along with those numbers. Negative 10t squared plus 10t equals n, where t is the number of minutes and N is the number of micrograms of epinephrine in that person's system at whatever time. All right, the question says, how long, so at what time, T equals, after an injection, will there be 210 micrograms of epinephrine in the bloodstream? Whew, this is a hard one. Okay, so 210 micrograms is N, right? It's the amount of epinephrine in that person's blood. So I should be able to use this equation and plug in a 210 for N. There we go. Now, doesn't this look like a quadratic? We have a T squared and a T. We can follow our rules for factoring or solving by factoring by moving everybody to the same side. So I subtracted over the 210. It looks like I can even GCF out a number this time. And remember, if I have a leading coefficient that's negative, I actually want to factor out a negative GCF. So I factored out a negative 10, leaving me with a trinomial of T squared minus 10T plus 21. And now my leftover polynomial looks like it could possibly be a basic factor. So let's try to keep factoring. I need numbers that multiply to 21 that add together to give me negative 10. I got negative 3 and negative 7. They multiply to 21, but add to give me negative 10. Now that I have my three factors set equal to 0, I can set each factor equal to 0 and solve. I ended up getting two answers. I got T equals 3 and T equals 7. Did you? Okay, but what does that mean about this scenario? What did T represent? Well, remember, T represented the minutes after you were injected with this drug. So what this is saying is that 3 minutes after you were injected, you had 210 micrograms of epinephrine in your system. But not only at 3 minutes, you also had 210 micrograms after 7 minutes. Now, does that make sense? Well, remember, when you're injected with this drug, it grows and then it comes back, right? So can I have 200 micrograms at 3 minutes and then again after 7 minutes? So it's okay to have 2 times. That should make sense in this scenario because when you inject the drug, it kind of increases the amount and then it decreases again. So I could have 210 at 2 different times in my bloodstream, after 3 minutes and after 7 minutes, making sure that I label it appropriately. All right, I hope those 2 examples helped. We'll do a couple more examples of word problems in the next video. You can never have enough examples, right?